A number of things where this could ultimately benefit society by taking these observations. First and foremost, we're talking about motions and things at the tops of clouds. There are a couple questions. One, we don't really understand turbulence very well. We know it happens. We know the types of processes that can lead to turbulence, but we don't have a really strong handle on why turbulence occurs in certain regions around a storm and not others for particular storms. In some cases it can be on one side of the storm. Another storm that looks very similar can be on the opposite side of the storm. It can be more above the storm or below the storm, depending on how the storm introduces different types of emotions in the atmosphere through waves. Just like you get waves and ripples in a pond, you get waves and ripples in the atmosphere when you have a storm that goes up and turns things up and generates all these waves. Well, ultimately, if we can understand turbulence better, we can better plan flights. So from the commercial side, if you're flying from LaGuardia to Denver or LaGuardia to Los Angeles or internationally, if you want to be flying anywhere, you have to know what predictions of turbulence are. If we can better understand turbulence in storms or just in the upper atmosphere in general, then we can better plan for these things and avoid those types of hazards with aircraft. So that's something where society could benefit. Another issue is it's really a current topic in the community, and it's not clear whether or not it's important. But if we look at storms that produce severe weather down here at the surface, there are a lot of interesting things that happen at the tops of these storms that we can detect from satellite. Well, one thing we can't do from satellite right now is look at the motions at the tops of these storms very well. Certainly not a lot of the waves and things that would lead to turbulence. But also, if we look at the storm top, it's not clear how motions at the top of the storm are connected to motions down near the surface. So if we have a storm that's rotating, that is able to produce a tornado down near the surface, is there similar rotation or related rotation? Is it connected at all to the process that's happening lower down at the storm? Is there something similar happening up near the storm top? And that's not clear, and that's something that we could address with these observations. To study one of these storms that's producing severe weather and to look at the motions at the top and determine whether or not we can use that information to better prepare for hazards down near the surface. So if we see a storm that goes up, has a certain type of rotation or dynamic signature to it, we can say, hey, this storm's going to produce severe weather in X amount of minutes. And because today with aircraft and satellites, we can get updates on storms more rapid than we can get with current capabilities on the ground from radars, that maybe we can increase the amount of lead time that we get for some of these storms. So that's another way that we can benefit society with this work. So ultimately, if we understand the processes, then we can better prepare for them. And in addition, if we understand the processes, we can better represent those in numerical models, which we use to forecast the weather. So if we get better forecasts of the weather, that ultimately will impact everyone, whether they're down here at the surface or you're an aviation engineer telling people where they need to fly, and or forecaster, planner, flight planner.